So in dealing with this same information about slopes of lines and parallel lines, we've talked about perpendicular. What we're going to do is work with finding the slope of a line given two coordinate points and then determine whether two lines are parallel, perpendicular, or neither. And this will come into play more so as we move through this unit, but it's really important to understand why these work the way that they work. Okay, so starting with the vocabulary, first thing is slope. Well, you have to know the equation for the slope. You absolutely have to. And so it's m equals y2 minus y1 over x2 minus x1. And it's the rate at which a graph either increases or decreases. Another way that you may have seen it written is rise over run. So you may have seen that before. One thing to be very careful with is this y2 right here is y with a 2 down at the bottom, not up at the top. It's not squared. So just like in the distance formula, it's down at the bottom, just to indicate that these two together are one coordinate point and these two together are one coordinate point. Perpendicular lines, we've already talked about, the fact that they intersect at 90 degrees. This is not new, but they have slopes whose products are equal to -1. And product means that when you multiply them, okay? So when you multiply them, you get a -1. And it's really, really important that you know that two lines are not perpendicular just because they intersect one another. It doesn't always make a 90-degree angle. So if you picture a road intersecting another road, they cross one another, but it's not always at 90 degrees. Sometimes it is, but a lot of times it's not. So it's really important to know just because they cross does not make them perpendicular. Okay, now I came up with this little Mr. Slope guy. Sorry, this is off a little, but this is to help you remember which way slopes slant. So a positive slope goes up to the right, a negative slope goes down to the right. An undefined slope, so the U is undefined. That is a vertical line, so it goes up and down. And then side to side is a zero slope. So that's your horizontal line. Now we have two forms, and these may actually be on your formula sheet for the SOL. I'm going to have to double check, but we have slope-intercept form, so it looks like this, y equals mx plus b. M is the slope, b is the y-intercept, and then your x and y is just a coordinate point. And remember that y-intercept is where it crosses the the y-axis. So it's always going to be where your x is 0 and then whatever your y value is. Then we have point slope form. And so if you look at this, this is actually a lot like just finding the slope equation, except the m is over here with the x's. But y and x will stay as variables, and then x1 and y1 would be a coordinate point, and m again is the slope still. So let's actually find the slope of some lines and see, how to use that equation or how to use those equations. So first thing when you're finding the slope is write out the equation every time. This helps you memorize it, makes your life much easier in the long run. So y2 minus y1 divided by x2 minus x1. So rise over run. So we take our y2, it doesn't matter which one you use, so you can do 4 minus 2 divided by, but since I used 4 first, I have to use -4 first on the bottom, minus 0. So we end up with m equals 2 divided by a -4, and always simplify as much as you possibly can. In this case, it simplifies to a -1/2. Now a second route of doing that same type of problem, and actually I think I have one more example of slope, and I'll go ahead and show you a second method. So method number 2 is from -2 to a +2. So -2 to a +2 would be a total of 4 over -9 to a +4, which would be a total of 13. And so your slope would be a 4 over 13. Now, just to show you how this would work using our equation, our formula, m equals y2 minus y1 over x2 minus x1. So when we do y2 minus y1, I did, oh, look at that. I did it backwards. It's 13 over 4. Goodness gracious. Sorry, it's y over x. See, even I make mistakes. All right, so negative 9 minus 4 divided by negative 2 minus 2. So we get negative 13 divided by a negative 4. Well, a negative over a negative becomes a positive, making our slope a positive 13 over 4. So remember that it's always y over x, kind of like the mistake I made right here. Be very careful with that, but you do have two methods in approaching your slope. Okay, so now we have to determine whether these are parallel, perpendicular, or neither. Well, referring back to our information that we have on parallel, parallel means they have the same slope, okay? Perpendicular means that when you multiply them, you get a negative 1. And then neither would be anything else. So we need to find the slope of Km and then find the slope of St. So I'm going to write M for slope of Km, the line. So y2 minus y1 divided by x2 minus x1. Be careful with your negative 1 minus 1. That is not a 0. It's a negative 2. So we get negative 14 divided by a negative 2, which gives us a positive 7. So the slope of line Km is 7. Now when we go to do the slope of St, so M and then St, remember we're doing slope of this line, is y1 or y2 minus y1, and it doesn't matter what order you use these in, as long as you use the corresponding pair with the top one. So see how negative 2 and negative 6 make a coordinate point together? You need to make sure to use them together. All right, and then, so we did negative 2 and then minus 2. So we end up with a negative 16 divided by, and we get a negative 4, which gives us a positive 4. So the slope of St is a positive 4. These would be neither. They are not the same, so it's 7 and 4, not the same. Perpendicular, perpendicular would mean that 7 times 4 would equal a negative 1, which it does not equal a negative 1. So it's not perpendicular, meaning it is neither. So one more example of this type. So we'll do the slope of line JY, and it's very important that you write these things correctly. So 10 minus a negative 8 divided by negative 4 minus 2. So 10 minus a negative means really 10 plus 8 divided by a negative 6. So we get 18 over a negative 6. So the slope of line JY is a negative 3. Now we come over here to do the slope of YX, so the slope, WX. So remember this is slope again. So let's do 2 minus a negative 7 divided by 1 minus 4. So we get 2 plus 7 divided by a negative 3, which is a 9 divided by a negative 3. And so we end up with a negative 3 as the slope of WX line. And so because these are exactly the same, these would be parallel. And it's because our slopes are the same. Okay, so now what we're going to do is find parallel slopes given the equation of a line, and then find perpendicular slopes given the equation of a line. So if I were to work with this information, we know that the form y equals mx plus b, that this right here is the slope. So y needs to be completely by itself. So in order to get y by itself, what I'm going to do is I'm going to add 2y to both sides. Now the reason I'm doing that is because the 2y is negative, and I like to deal with positive variables that I'm solving for. So I get 3x equals 8 plus 2y. subtract 8 from both sides, and remember you can only combine like terms, so 3x minus 8 equals 2y, and then I'm going to divide by 2. Now at this point right here, the 2's over here become just a 1, so we get y equals, and all I'm doing is flipping the order, and I'm going to write 3x over 2 and then minus 8 over 2, and I'm going to simplify each one. So this would be 3 over 2 times x minus 4. So a slope that would be parallel would be 3 over 2, because that's the slope of the line given to us right here. See, it's not so bad. All right, and then for our very last example, we do one that is perpendicular. So again, we need to get y by itself. Y is already a positive, so I'm going to start with subtracting 3x from both sides. Now, even though I'm doing that subtraction, I'm going to keep this first, a negative 3x, only because I want it to stay in the form y equals mx plus b. Okay, so then divide by 4, and remember you want to divide everything individually by 4, just to keep things easy. So we get y equals negative 3/4 x plus 2. So our slope then, if I come up here, our slope is a negative 3/4. Well, that would mean our perpendicular slope would need to be the opposite sign, so I make it positive, and then we're going to flip it upside down, so 4/3. And that would be because if you take a negative 3/4 and multiply it by 4/3, you get negative 12 over 12, which is a negative 1. So that's how you know for sure that you have this correct. So make sure you have everything written down and come in with any questions that you may have.